student farm, and so I have gotten a lot of hands-on experience with different soil types and really seeing what I was learning about in the classroom. So that's a little bit about what qualifies me to be talking about this today. So yes, so I just want to start by kind of getting an idea of how much you guys know about soil already. So does anybody want to say what is soil? What? Yeah.
Is it dirt with nutrients?
Dirt with nutrients? What's dirt?
Weathered parent material.
Okay, okay.
Weathered what?
Parent material. Like
Okay.
what was the rock that broke down to make the dirt?
Okay, yeah. And that's something that I also, before taking a soil science class, I was thinking, what is that brown stuff? Like, what actually is this made of? And it has 4 main constituents. So it's about 45% of it is weathered parent material, which is literally, it's just weathered rocks. It's minerals that have been ground down so small that they just begin to take on the few properties that rocks or pebbles just don't have. And then it also, 25% of that also is water, and then 25% is air. In a healthy soil that is not compacted, those are the ratios that you'll see on your handout. And then the other 5% of it in a healthy soil is 5% organic matter, and that also contains a soil that's really low in organic matter might be like 1 or 2% organic matter, or even less than that. And then once you start getting up above like 8% organic matter, it doesn't really do as much for you in terms of like in an agricultural context. If a farmer had 8% organic matter in their field, then any more than that is just going to be diminishing returns. And so, but 5% is a really healthy amount that's common for a healthy soil. And so that organic matter is made up of both living and dead organisms. So organic matter is just basically anything that contains carbon, more or less. And so all of the organisms that have lived in the soil and died in the soil, all of the plant debris, the rotting leaves, that is some of the organic matter in the soil. Or like if you compost, if you mulch, but then also all of the living organisms account for that as well. And a lot of people don't realize how much life there is in the soil, and it's actually quite incredible. In a single pinch of healthy soil, there are more than 1 billion organisms of different species in that single pinch of soil. And think about how diverse that's in a single pinch of healthy soil. And we only know 1% of those organisms. We only named 1% of those organisms. So there's a lot that we don't know about soil. There's a lot that we don't understand about the life that's going on in it. But that just kind of goes to show just how much life there is in a healthy soil. And a lot of people, when they talk about dirt, they don't think about it as a habitat, as a living thing. But it's just as much a habitat as the ocean or a conifer forest. And so going back to the mineral, so the mineral portion of it, that is sand, silt, and clay, and you guys have probably heard of those 3 words. So sand is the largest, and then silt is medium, and then clay is the smallest. And then I also have a picture of that on your handout, just for, you can see, it's almost like the solar system maps where you have the sun and how tiny the earth is. And clay actually, and those each are just a slightly more weathered version of the next one. And so they may all be made of the same mineral, which could be a lot of different things. You might have like volcanic rock that has weathered down and is really dark, and that might help contribute to why you might have a dark soil. There are other things that can contribute to that. Or it might be some kind of limestone that's really, really weathered down. But clay actually is very interesting because it's not round, it's flat. It's almost like these little Oh, this is a highlighter, not my, not my exposed.
Is that why it compacts so readily?
Yes. I'm gonna get to that.
Go with me, sorry.
No, that's great. I like that you get into it. So yeah, so clay, it's almost kind of hexagonal in shape. And so all these little plates that can stack up on top of each other, but then they can also be like that, they can be that, they can just be all over the place, or in a really compacted soil, they might just be all stacked just like dishes in your cabinet. And then that's what makes the brick-like soil that many of us have had the pleasure to find in our gardens.
The annual battle.
Yes, yes. But clay is physically so small that it cannot get any smaller. And because of that, it takes on this whole new set of chemical capabilities. So sand and silt cannot hold nutrients, but clay is so small that it becomes charged, and that it forms ionic bonds with nutrients. And so clay is negatively charged, and a lot of our nutrients are positively charged, like magnesium ion, calcium ion, and so clay is able to hold on to those nutrients in a way that sand and silt just cannot. Also, if anybody has any questions or anything to say, please.
Does that mean like the soil will, or like the clay will also not give back those nutrients? Like it's holding on to them in a way that it's not going to like share it with your plants?
No, there is, and I can talk about a little bit of the chemistry about how that happens as well, and I'm actually going to talk about that a little bit.
So I just wanted to clarify that any parent material can be clay if it's broken, if it's weathered down to the right.
It has to be a mineral. So, and I don't know exactly what the definition of a mineral is, but that's a good question.
But you mentioned like a couple like limestone or volcanic rock, so both of those could be weathered down.
Limestone is calcium. I don't know as much about limestone, and I wish that I knew like what the chemical formula was for like feldspar or something like that, but so I don't know about any of those because I don't know the chemistry behind all of those, but something.
Lots of them can become
a lot of
clay
them
anyway.
can be.
Okay.
Yeah.
I was just curious.
Yeah. No, that's a great question. Yeah, and I don't have all the answers, but I still invite you to ask questions. Okay, so then from there, I want to talk about pore sizes and why that's important. So there are large pores, medium pores, small pores, and having a diversity of pore sizes in your soil is very conducive to plant growth. So I guess what I mean, so let me talk about, so if we have a sandy soil, then imagine those are little particles of sand, and they can kind of really all nest in to each other like that because they're more or less round, spherical. But then if you have actually, that's but then we were talking about with the clay how it's flat and it can just stack in all different ways. You actually end up having more space with a clay soil that is not compacted than you would with a sandy soil. So that, and the shape of the clay particles contributes to that, but then there are ways that you can also I'm getting ahead of myself. So with the sand, you have a lot of large pore spaces, and so the water just drains right through. If anybody has ever worked with sandy soil, then you know that it just doesn't hold much water. And then conversely, a lot of us have clay soil, and we know that it holds too much water sometimes. A lot of people deal with that in the Willamette Valley, and that the story behind that is in Montana. There was a glacial Lake Missoula. So back, I don't even know how many thousands of years ago, there was a huge lake, and it was sort of in this valley that was blocked by a glacier. So the glacier was acting like a dam. But then with the end of the last ice age, that glacier melted, and all of that water just broke through, and it washed all down Washington through the Columbia River. And then the Willamette Valley already naturally was a valley, but that water came into the valley, filled it, and then over time the water receded. I don't remember if it was a hot climate evaporated it or if it just drained out, but that flooding event actually happened hundreds of times. I wish that I remembered the exact number, but every time it happened, it was just long enough that all of the clay settled out of that water in the lake that was in the Willamette Valley. And after just hundreds of times of that happening, we just have this super flat clay soil. You know, if you've ever been driving on I-5, it's seen just so flat. That's how, because it just settled out from the water. Yeah, but then if you're near like the Willamette River, there's a lot more sandy soil near the Willamette River, and that's because that water is moving so quickly that the clay does not have enough time to deposit. And so since sand is heavier, the sand deposits first, but the clay just keeps on carrying on in the water. So if you are lucky and you live next to the river and you have some sandy soil, and I have an example of sandy soil from next to the river, then that is the story behind that. So anyway, back to pore sizes. So the large pores, the water just drains through it. But micro pores, once you get small enough, water, it starts to interact differently with the surfaces of or the forces of cohesion, which, you know, like how water droplets will stay on the side of your glass. Those forces actually become so strong when the pore size is small enough that the water just holds onto the surfaces of the minerals, of the mineral particles, and it's the plant is not able to draw that out, but then it stays wet in it. So it's interesting because your soil can be wet, but if it's all micropores, then that water is not accessible. But same thing if you only have macropores in your soil, which are those large pores, then the water just drains right through and it can't hold any water for your plants, you know, for later use. And so, with that, what you want in your soil is that diversity of pore sizes, because the large pores allow for drainage, but those small pores hold water for later use. What really helps with that is aggregation, which that's when organic matter comes into play. And organic matter is like the glue that holds these particles together into aggregates. Have you ever seen a really healthy soil that just, it has those little pieces that just keep breaking down smaller and smaller and smaller? And maybe you see a lot of fibers of organic matter in there, then those are aggregates. And those allow us to have that diversity of pore sizes, so that water both doesn't just sit in the soil and rot our roots, but also is accessible for later on. So, and I'll talk more about organic matter in a little bit because it's so important, and that'll be my big spiel. But so, how do you figure out what kind of soil you have? Does anybody, like, what kind of soils are people working with here? How would you describe your soil?
Clay.
So much
Clay. Okay. Super poor draining.
Except for when you have to
Too much compost? That can also potentially be different. Yeah. Okay. Yes. Okay. yeah, a lot of people who come here have that heavy clay soil. A lot of people will go to buy a tree, and we always recommend that you amend with compost when you buy a tree because of that poor draining soil. And a lot of people, I think, don't really realize that plants just cannot grow in a soil that's like brick material. It just holds too much water. It's like potting your plant in a pot with no drain hole. And the roots are not always strong enough to penetrate out into that soil. And so that's why we always recommend amending with some compost. But anyway, so on your handout, I believe it's the last page, the very last page, there's a texture by feel flowchart. And this is something that you can take home and you can kind of figure out if you want to get your hands dirty and kind of get a little intimate with your soil, then that's something you can take home and you can figure out at least what some information about your soil. So I have these different samples of soils that I have collected. I drove over from the coast the other day, and so I started at the coast and I took a couple samples just in my way over here to the valley. So my first one that I collected, if anybody wants to just feel it, then just tell me what you think it is. Do you think it has a lot of clay, a lot of silt, a lot of sand?
It seems to be sand.
Yeah, basically pure sand, right? Do you feel anything else in there? Oh, in this. Yeah. Does anybody else want to feel? Super sandy,
You've had
right?
that before.
Yeah.
I was gonna say that's
Like
not
maybe
like
some
my
clay,
soil.
maybe some clay and
So my soil, like, it can sit there and like make like mold
I'm gonna
stuff.
talk about that too. Yeah. Does anybody else want to?
Like clay sand. It's got a little bit of like a grit, but yeah, it's got a red color.
Would you like to feel? You good?
So
So that's an example of a super sandy soil, and so like my parents live over on the coast. And they have a cranberry farm, and that sand is really great for the cranberries because they just like a super well draining soil. But it also rains so much that you don't really need your soil to hold a ton of water because you're just gonna get some more like the next day.
exactly. Well, right.
And so yeah, that's a very, very sandy soil. Lots of macropores. And then my next one. Tell me what you think about that. Pretty hard. I mean, this right here, I think that's just a rock. Yeah, yeah. Yeah. Organic, yeah, yeah. It looks like ferns and dead tree needles and twigs and. Yeah, yeah.
Where'd you get this one?
This one was just outside of Mapleton. It was just in the side of a hill on the highway.
Yeah, like forest.
Yeah.
Like,
Yeah.
like it's got a lot less sandier, but
Yeah.
like
Mhm.
still a lot of grit and moss and.
Mm-hmm. Yeah. You just want to look at it. Yeah.
And then she'll probably
Yeah.
and,
So, tons of
it's very
organic
like
matter in that.
like
There's actually basically no sand, silt, or clay. This is basically just organic matter.
yeah.
That's not super. What's that? Yeah, I mean this isn't it. Yeah, the pores are too large, and there are other reasons why you can like potting soil. A lot of the time, it has a huge percentage of organic matter in it, and I wish I could remember more about why, like in a garden situation, if you're planting in the ground or in a raised bed, then you're gonna want some more soil. like mineral content than that. But this is also basically just right off the surface of the soil, so I didn't dig down super deep. But that's an example of a lot of organic matter, which also is known as humus. You guys might have heard the word humus before.
So did I understand you correctly that potting soil is so much organic matter that when you plant something in it, it may not be the best for your plant?
No, that's not true. And I know a lot less about potting soil and the details about that. So the people who are making that stuff know what they're doing, and like for a house plant, it works totally fine for them. So I wouldn't say that.
But for like your raised gardens and
For
stuff,
your raised
you need
garden.
to mix it as well.
I would not use potting soil in your raised garden, because potting soil, since it has so much organic matter in it, it holds a ton of moisture, because organic matter holds 5 times its weight in water. And so if you stick it outside and it rains a ton, then you're just gonna have soup, and there's gonna be too much water, and your plants, the roots are gonna drown. Because plants require air for gas exchange, and so yes. Does that answer your question?
I know,
Kind of.
in the sense that, you're probably gonna go a step further later, but
Okay.
what do you mix with the potting soil? If your
Okay.
garden is all clay, my dirt at home is all clay.
Okay.
I don't wanna put that in the pot and try to plant my tomato.
Right. Okay.
But you're probably gonna go through that a little bit later.
Yes. Well. So what are you planting in your pot?
Well, vegetables.
Vegetables.
Mhm.
Okay.
Yeah, zucchini or.
Yeah. And I mean, and that would work fine if you had a pot and you had like black gold potting soil and you put your tomato in there. It'd be fine. It would work. But what I guess, and it doesn't really rain much here in the summertime, and so it may not be as much of a concern. If you just have that pot sitting outside, then it's probably not going to hold too much water for your tomato if you're watering properly. So
Yeah, with raised beds.
with a raised bed, there's so much volume there that not all of that, there are not roots in all of that volume of soil, and so there's a ton of moisture that's not being taken up by roots, so that can actually rot your roots. So the larger your volume of soil, the less you would want to do potting soil, and I would go instead with a raised bed mix, which has some more. It's designed. It still holds moisture, but not as much as potting soils. Yes. Yeah. And then some people, I think that it may also have mineral content in it. I'm not totally sure, but some people will also use mineral soil in their raised beds mixed with compost. Yeah. So, I guess, yeah, so this was one more example. Well, there's 2 more examples, but tell me what you think.
Yeah.
Yeah. Does that look familiar?
Yeah. Still some clay, but not a huge
Depending on which part of the yard we're in, yeah. Did you want to see back here? Yeah. I don't know if you want to.
Oh, this is familiar.
Yeah. Yeah.
Just watching everybody else break it
Yeah,
up kind of looks silty to me.
Oh yes.
Okay, over there.
Smooth.
So this I scooped out of a farmer's field just outside of Ocean City. I believe they're a grass farmer. So this is our more typical Willamette Valley clay soil. It's a lot higher in clay. If you rub it,
feel a difference in sizes of particles right away. It's like
yeah.
it feels pretty consistently packed.
Yes. Yeah. I would agree with you. It seems like there's definitely some organic matter in it, but
It's been worked
not
and
big
reworked and
chunks.
reworked and
yeah,
reworked.
this is probably a soil that's been tilled and kind of compacted.
The more
um,
strata.
Yeah, and so compaction is, you know, a big concern, as we said, with clay soil, because they stack like that. So
It holds together.
so this has a lot more micropores, but a lot fewer macropores than like that standard soil. Okay, and this is my final example.
Very nice.
Yeah. And if you want a paper towel, then please help yourself.
It's like my great grandma's house. She had like an amazing garden. That was my favorite.
It's like a slight kind of sandy, but it's so mineral.
That's better.
Yeah, there's one.
I like that.
When I was just spraying off the excavator, I was literally like, I was getting chunks of like just lift because it was noticeably lighter than the soil. It was like,
Where did that one come from?
This one came from the OSU student farm, which is just across the river.
Yeah.
And so this is an example of a soil that has a lot more sand in it because it's near the river. And when, like, if anyone remembers a couple years ago, and in the past when it's flooded super high, like Tristan Tree is covered. The student farm is right next to Tristan Tree, and so it's gotten a lot of sand deposited there from those flooding events. But it's this is I believe it's a sandy loam, but it's been organically managed for 20 years. The soil science professor actually is in charge of the student farm, and so he commands
He's
us
got a
little
good eye on it, I
workers to-
imagine.
What's
I
that?
said he's got a good eye on it, I imagine.
Yeah, and so this is a beautiful soil. And another thing, you might have noticed color differences. So like this,
How orange
you know,
it
is quite a bit different from that. And then even with the clay is a little bit more kind of reddish, not as dark as that. And that color is also an indicator of nutrient content in your soil. The darker the soil, generally, the higher in nutrients it is. And you want your soil to look like crumbled chocolate cake, just like this. Yes. Yeah. And then also, if it's a little more red, then it might have more like a higher iron content. And so the color also tells you about like what it came from. So there might be a lot more quartz in this because it's sand. And so those. So that's, you can see, and also the pore sizes in this. Thank you. There are those aggregates that have the micropores, but also just look at how crumbly it is and how well water would be able to infiltrate through that. So this is an example of, it has a diversity of micropores, it has a diversity of mineral particle sizes, because there is still sand in there, there's silt and there's clay. So that's a really beautiful soil.
I would imagine it's easier for roots to penetrate it also.
Yes, precisely, which could be good or bad, you know, for the weeds. The weeds love it, but also
Don't put the mint in there.
yeah, no, don't put the mint in there. Put the mint in whatever
Yeah, there you go.
the grass. So those are our different soil types. And so figuring out what kind of soil you have, you can take a sample of your soil, and you can use the flow chart for this at home. But just to demonstrate something with clay. So first, the first step is something like wetting the sand, or just, you can kind of feel how much sand content is in it just by getting your soil wet and just kind of like stirring it around. Some people will put some in their mouth, and you know, if you've ever got sand in your mouth, then you know what that is like. But then for clay, a really nifty thing about clay
You can make stuff with
is that for every, let's see if I'm getting a little There's ribboning, which you may have heard of before. You guys, I think, were talking about it kind of without maybe knowing what it is. But you just get your soil just kind of damp enough to work with, just kind of like that, like if you wanted to make a little pot or something. And then you just, but you kind of take it between your thumb and forefinger, and it's smooth. It's not the best.
So
But
what is
you-
the ribboning? Is that the?
This is for checking how much clay.
Oh, okay.
And so for every inch you can ribbon this, it's 10% clay content, roughly.
Okay.
And so that's the part, that's just how you do that. I think that's in the little handout right there. But that's sometimes, I don't know, if you're in a new place, I just like to play with the soil when I go to new places.
And that's just how you do it, feed it through your
Yeah, you just
hands
feed it
like
through,
that.
and then you measure until it breaks under its own weight. So that guy is, there we go. And then after it breaks under its own weight, you measure that, and that's about like 10% clay content for every inch you can. And do it a couple times, because sometimes you do it better than other times. But so yes. Okay. All right. So, and then also, so that you can just kind of play around with your own soil and use that flow chart, and just make those observations to get a little bit of an understanding of what kind of soil you have. And then there are some other really interesting resources. So, on the NRCS website, or you can Google soil. What is it? Soil web? Yeah, if you Google soil web, and I think that I have that on one of the pages, there's a helpful resources section, and I have it under there. But yeah, so you can go to soil web, and then it'll come up with a map of the United States, and you can type in your address, and then it will zoom into your address, and it may or may not be the most intuitive website, but there are tabs up at the top, and it'll say like area of interest, and you might want to like YouTube a little tutorial. I wish I could give you a tutorial now, but the Wi-Fi is not good enough. But you can select an area of interest, so you select maybe your little garden bed, and then it will display a soil map that tells you the different soils that are in your garden, or whatever area you're interested in looking at. So it might be like a Chehalis, which I think is higher in sand content. And then there is such a wealth of information on that website. Once you click on one of the soils that's in your area of interest, it just comes up with what kind of crops grow well in it, the drainage properties, the percent sand silt clay. There's so much information on that website. So I really recommend that you try to figure out if you can look at your garden and figure out what kind of soil is in it. It will tell you so much about it. But
Can you
there's
tell us
also
the website again?
Soil
Yeah,
web survey or just
soil web survey.
Soil web survey. Right. Making sure we're on the right spot.
It's on the little
It's
panel.
on this page. Bottom.
Oh,
Yeah.
okay.
Oh, right there.
And then there's also a phone app that's just called Soil Web. And I don't know if you can find it on the NRCS website, or you could go in your app store and look up Soil Web. And it will just use your GPS coordinates. This might be easier. It'll use your GPS coordinates to figure out where you are and what kind of soil you're standing on. And these things are not 100% accurate, but it's really interesting. Like I could look up right now and see what kind of soil we were on and how its drainage is. So that has a wealth of information on that. So that's for figuring out what kind of soil you have. And then next, and if people need to like get up and go at any point, then I won't be offended. But I'm going to talk about organic matter, pH, and fertilizer. And then that I think will be,
A raspberry pot that goes in a pot.
yeah, that'll be the rest of it. So organic matter, we've already talked about a little bit, but the importance of organic matter lies a lot in that aggregation and creating the diverse pore sizes but also the fact that it does hold 5 times its own weight in water. And so last year it was, or every summer here, it just gets super dry, it just stops raining. And so we want our soil to be able to hold as much moisture as it can, so that our plants survive and are more tolerant to any droughts. And organic matter is really the key for doing that. It improves the drainage of your soil by creating those large macro pores. A lot of people ask if they have a heavy clay soil, like we saw with this grass farmer. They ask, can I just add sand to my soil to improve the drainage? But that doesn't work, and I have this little statistic right here on my computer. Because I hear this a lot in working here. And so if you had a 1,000 square foot garden of a typical soil, it's considered to have 23 tons of soil in the top 6 inches. So 1,000 square feet, 23 tons of soil. And so if you wanted to balance like 30% sand, 30% silt, 30% clay soil, then you would need 8 tons of sand. Wait, to change your soil texture by 5%, you would need 2.3 tons of sand for 1,000 square feet, which is 5 half-ton pickup loads. So it's just not as feasible. And it doesn't even have as many benefits as organic matter because they can't hold nutrients. Organic matter can. Only clay and organic matter can hold those ions because they have that charge. So organic matter is where it's at. It improves the structure of your soil, the drainage, and the nutrient holding capabilities of it. And so that's why we recommend that you add compost when you're planting a plant, or mulching every fall is a really great idea. At least mulching once a year with 2 to 3 inches of mulch with like a nice compost is what we really recommend. And the more broken down the compost is, the faster the nutrients are going to be available to the plants. And if you have a not super well broken down compost, it can actually lock up nitrogen. Don't use bark chips, or bark chips, and even bark mulch can lock up a little bit of nitrogen as well.
So what's the best way to work it in? If I would assume top dressing alone is not going to be sufficient, or do you want those layers of strata so you have different levels that are providing different nutrients?
Right. So the best way to work it in is I don't know if you've ever seen a broad fork, but physically getting it in there, whether you have just a turning fork or a broad fork are super nice for doing larger areas.
But if we already have established plants and we're just trying to improve the overall health of the soil, digging around the plants, just going in what, like 4 inches?
Yeah, so actually you don't really need to work it in. If you just had a garden with established plants, just putting 2 to 3 inches of mulch on the top of the soil, the worms will come and pull it down in. So you don't have to dig it in. Yeah.
The critters do.
Yes. And worms are also great because they create large pore sizes and pathways that roots can go in. So if you have a lot of worms in your soil, then you're doing something.
My soil.
You're doing something well then. So let's see. So basically, and my soil science professor always says the answer is add organic matter. Right? It improves a lot of different aspects of soil health. So that yearly mulching is a really great idea. Mixing some in when you're not mulch, but compost, mixing it in when you plant is a really great idea. Let's see. And it just holds more nutrients, so if you add fertilizer, less of it is just going to run out in the water, and more of it's going to be held and just available to your plant. So,
if you have a lot of flower beds with bark mulch on it,
yes.
Is that beneficial at all, or is it, is it worth like scraping it back to put down compost, or?
So that's a great question. So
how do you keep that soil healthy?
If your plants are looking fine, and this is more, it's not that makes your soil unhealthy by like adding undecomposed stuff to it. at that point it's more a concern of your plants. So if you notice a lot of them have yellow leaves, that's because the microbes that eat those bark chips to break it down require nitrogen to do that. And so they take that away from your plants. So if you have yellowing plants, it could be a nitrogen deficiency. But if your plants look fine, then you could just add a little extra nitrogen from a fertilizer, and that would make up for that difference.
Okay.
Yeah. Okay, so that's about organic matter. And then, so 2 more things that I wanted to talk about that I think are important for gardeners to know. The first one is pH, which is, how acidic or alkaline your soil is. And it's a measure of how many free hydrogen ions are present in a substance. And so here is where I wanted to talk about earlier. I think it was one of you asked about if hydrogen is present in the soil, or no, if the nutrients are present on clay, then how do they get off of the clay and into the plant? So with this, so we have that clay or that organic material that has the negative charge. Or we have organic matter here. It's got negative charges, and we have our little ions that are binding to it, and I don't remember all the proper whatever. But we have our positively charged nutrients that are bound to those. That's magnesium. And so and this kind of is going to go over into our fertilizer talk also, but so we have a plant root here that's coming down. And that plant root is going to respire CO2, carbon dioxide, and there's water all around in here, and that's H2O. And so when that CO2 combines with the H2O, it produces 2 hydrogen ions, which are also positively charged, and then carbonate or something like that. It's like some CO3 2 minus or whatever. And so the plant, that hydrogen ion, this clay and that organic matter wants to hold on to that hydrogen ion more than it wants to hold on to these nutrients. It's a smaller atom, and that's just easier for other atoms to hold on to. And so that hydrogen is going to dislodge those nutrients on the clay or the organic matter surface, and then that frees that up to be taken up by the plant, and now that hydrogen is where these nutrients used to be. And so when you have a really acidic soil, which a lot of our Willamette Valley soils tend to be acidic, it has all of these free hydrogen ions, which here are just going to replace every spot that's available that could be held by nutrients. It's going to come in and take the places of those. And so what you have are all of these nutrients that actually just are not present for the plant root to take up. And so having an acidic soil reduces the availability of certain nutrients, and that is that other picture that's in your handout.
So is that what, these are not available? Is that what that means in the acidic soil, this is not available in the green area?
The green area is where it is available. So an acidic soil would be like a 4.5 or a 5. And so it's this little narrow part, so that's not very available. That's more available, that's more available. The iron is super available.
Okay, so things like phosphate, magnesium,
Things like potatoes.
lots of phosphate, and that's not available.
Correct. Yeah. They're super available out of here. Yeah. Yeah, does that make sense to people, that graphic for interpreting?
So you need to be adding nitrogen, phosphorus, calcium to your soils if you're really acidic.
No, what you need to do is adjust your pH for that.
Then you've got catastrophic soil.
Yes.
How does that work?
So like if you need to make it more alkaline, you add lime. If you need to make it more acidic, There are different things you can add. Sometimes sulfur is used, and we have acidifier in there. I don't know exactly what is in it. But, so that was a really great question. She asked, if you have really acidic soil, then should I add fertilizer to make up for those nutrients not being there? No, because there's no place for them to bind on here. It'll all just wash out. So what you need to do is adjust your pH so that it's conducive to growing the plants that you want to grow. So like a lot of people, like my coworker had a pH of 4 in her soil, which is super acidic, and her blueberries were doing great because blueberries love acidic soil, but nothing else was growing, and she amended her soil so that it was more around pH of 7, and now things are growing well. Those nutrients are available to it.
Does it matter when you add the lime and all that kind of stuff? Do you do it any time of year? Because I always see farmers putting it on in the spring, is it?
That's a great
Early
question.
spring, like March or something?
I don't know the answer to that for sure.
I would assume that you would want to add it before you're planting stuff, because if you add it before, then your plants are going to have a better start.
Yes.
And then they'll, from then on, will continue to thrive. Like, you don't want to start your plants off stressed and then have to like make up for that later.
Yes.
You would want them to have a strong start versus like having to backpedal a little bit and be like, oh shoot, they're dying. Now I have to like help them go back to where they need to be.
Yes.
And the farmers are working the line in, right? I see them dust it and then they go through.
I believe so.
plants,
I believe so. And I know that no-till, there's a lot of research is going into no-till, and no-till is the healthiest thing for the soil because it wants to organize itself down there. And humans coming in and digging it up, it just disrupts that natural kind of self-organization. So
But digging a single hole in your garden to accommodate
Yeah.
a 1 gallon plant is fine. But
That's
you're trying
totally-
not to disrupt the 6 to 8 inches adjacent to it, so it has those levels.
yeah, and on the scale of the home garden, it's really interesting. And a lot of these things, I mean, I'm coming from more of like an agricultural sort of background, and so I'm thinking a lot of the time about like farm fields when I talk about soil. But for the home gardener, a lot of these things are not as much of concern. You don't want to compact your soil still. You still want to add organic matter. But like disturbing your soil, you still want to disturb your soil as little as possible. But you're probably not tilling your rose bed, I'm guessing. You know.
Unless you have layers of rock and then you really want to disturb the layers of rock because you want something other than rock there.
Yeah. And,
But doesn't tilling clay soil help break it up?
it can, but over time, the more you do till it, the more those flat plates are just gonna start to stack together, and then they want to stay stacked together like that more than they want to be all.
But if you're tilling in like a manure or something like that,
Then
does that
that that's okay. Like on the scale of the home garden, that's fine.
Tilling is like fluffing up the top. It like as far as your tines go down, it's fluffing up that, but then it's also compacting things that are underneath of your tines. So like if you're continually tilling over and over again, it's compacting the soil underneath of where your tillers are rotating, and it's fluffing up the top layers, kind of a thing. So you could be compacting the stuff underneath, which you don't want because you want it to still be available. And
I think what she's asking was is like the first time.
yeah, first time is like usually kind of almost necessary to
Yeah.
kind of like mix it all up, but then after
Yeah.
that, just layering on top and keeping the nutrients piled is a good thing instead of tilling every single year.
Precisely. That's exactly right. Yeah.
As far as pH goes, is the goal to be neutral, slightly acidic? What's the goal?
Well, the goal is to be pretty neutral. So where all those green sections are, that's where those nutrients are most available. So a lot of them are kind of these major ones, like the nitrogen, phosphorus, potassium, which is the NPK in fertilizers. They're most available. You can see around 7 to 7.5. So that's the goal for most people's situations. If you're a blueberry farmer, then you would want to be more down like around 5.5 and 5. but for the home gardener, yes, a neutral pH is and then
I'm sorry to
yeah,
interrupt.
go ahead.
Is as far as a plant by plant basis, is there a good resource that tells you what this plant particularly likes? Is it going to be more like the blueberries, or is it going to be something that really relies more on the NPK range?
That's a great question. I don't know of one off the top of my head.
You want like a book resource?
Well, just in general, like I know roadies do well in the city,
Yeah.
but say maybe not so much for columbines or for I don't know, something else. Diarrhea.
Yeah, I don't know off the top of my head of any one definitive source. I know when you look up on the internet, of course anybody can post whatever on the internet.
Exactly.
So if you find sources that are like .edu, .org, those are going to be a lot more reliable than like myhomegardenblog.com
Yeah.
or whatever. So, yeah, did you have any resources that you
I was
know
just
of?
looking up the book that I have. It is a really good resource, but I can't remember if it tells about pH stuff. So I was
Okay.
gonna look it up actually.
I think like the Sunset Western Garden
Yeah.
book, like
Yeah.
that one, it will say, but you have to read it. There's not a table. They'll be like, oh, as you're
Yeah.
reading through like these, oh, they like this soil and this drainage or this aspect. I mean, sometimes even on the plant tags, they
And
have
depending
that.
on what year that Sunset Garden guide was, because it's
True.
changed a lot over the years.
That's true. That's true.
Yes, yeah, thank you for that.
It's like having a favorite cookbook. It's like, yeah, I don't want the Western Garden book from the 80s. I
Right.
want the 70s. Yeah. I want that favorite recipe in.
Yes. So then that brings us to fertilizer. A lot of people, ask us questions about fertilizer of like, what are those three numbers? What ratios and numbers like should I be adding of that? So the three numbers are NPK, which is nitrogen, phosphorus, potassium, which I believe are the first three nutrients on that pH chart. And those are the three most vital nutrients to plant growth. Nitrogen is really important for chlorophyll production. And so, like we were saying earlier, if your plants are turning kind of yellow, they might be deficient in nitrogen because they're not able to produce that chlorophyll. And then the phosphorus, which is the P. And these things are complicated and they're involved in a lot of different, plants are sometimes just as complicated as us when it comes to what's going on in their physiology. So these things serve a lot of different roles, but in general, the phosphorus is a major component of their energy, like the plant having energy to grow, to do all these things. And then the potassium activates the enzymes and it moves nutrients through the tissues. So those are the NPK that you see on fertilizer bags, and the three most important ones. And then so knowing like what kind of fertilizer do I need to add to my garden. A lot of people come in looking for 16. They think that they need like a huge dose of nitrogen fertilizer if they see something turning yellow. But you can do that. You can do things like that. But adding that high of numbers of things sometimes can throw off the biology in your soil. That can be toxic to some of those microorganisms, which holistically is not great for the health of your garden because those microorganisms have relationships with your plant roots. They can help your plants take up nutrients. And so, I mean, I don't know. From a holistic organic standpoint, that's not the greatest option. And it's also sort of like having like a donut and coffee for breakfast. It's like this huge jolt of energy, but then a lot of that nitrogen ends up just getting washed away in the waters because nitrogen is very mobile. It doesn't stay in the soil as much, and then that gives you issues with water contamination. You can get nitrates in the water. That's a contaminant. So generally in the home, if you have just a flower bed, I generally don't recommend conventional fertilizers that have those really high numbers. Organic is more like for breakfast if you eat something with like some vegetables and some beans and like something that's going to sustain you through your day. It's going to take a little bit longer to become available to to the plant because it has to break down a little bit more, but it's going to sustain the plant for longer. It's better for the biology in the life, and so holistically, if that biology is healthier, your plant also is going to be healthier. And then in terms of the ratios, things with a high nitrogen content are going to promote a lot of foliage growth. So if you're growing grasses, if you're growing conifers, then you want more of that nitrogen. But if you have too much nitrogen, that can prevent things from flowering sometimes. So sometimes people will have like a rhododendron that's just gorgeous. It's like super dark green, but there are no flowers on it or something like that. So that could be that you have too much nitrogen. And at that point, you might want to add a fertilizer that's lower in the nitrogen and a little higher in the other two. But for all intents and purposes, I mean, and the Spoma products, they help you figure out, like, I don't know all the details about how much nitrogen does a rhodie need and how much does a hydrangea need, but the packaging is pretty reliable on those. And so you can add just a balanced fertilizer to your garden every year, or if you have a big patch of rhodies, then you might get a rhodie fertilizer. And but a lot of people will just buy like we have an organic 555, which is balanced, and you can just add that if you don't want to like go to the trouble to figure out like what might be a little bit better. But so yeah, and then also doing a test of your soil. I really recommend that everybody does this because it will tell you what your pH is, and even if you have a whole bunch of nutrients, they're not available to your plant at all if your pH is not, if it's too high or if it's too low. And so, and then also this is sort of just like going to the doctor and getting a physical and like seeing if anything might be a little off. It kind of gives you a baseline that you can work with from there. So don't add a ton of nitrogen fertilizer if you don't know that you don't need to be doing that, because there are other things that can turn your plant yellow. So this is just the best way to know, what should I really be doing, gives you a baseline. So, yeah, I mean, and then compost also adds some nutrients. So like our Harvest Supreme has chicken manure in it, which it's a good source of nitrogen for your plants. And I mean, so all of these plants have been bred a lot to make them really special and beautiful and have huge flowers. And we keep them in these sort of unnatural environments that they're not native to, unless we're planting a bunch of natives. And so when like a plant in the wild, if you think about a forest and like a spruce tree in the forest, it has all of this organic matter being worked into the soil very, very slowly. There are no like gnomes out fertilizing things. It's all just from leaves dying and things decaying. And so plants in the wild get their nutrients mostly just from like other things dying and decaying. But in the home landscape, we don't have that as much. We generally, I mean, it's good practice to clean things up out of your garden. If it can harbor like diseases if you like leave all your rhodie leaves of your rhodie. But there are differing opinions about that. But so our plants don't get as many nutrients from just breaking down organic matter in the home garden, which is why we fertilize with things. Just like how we in modern society, a lot of the time, we don't eat enough whole foods or nutritious foods, and so we might take a multivitamin every day. This is sort of like vitamins for plants. You're ensuring that they're getting all the nutrients that they need. So like native plants, you may not need to fertilize as much because they were designed to grow here. But if in your home garden, I don't know, it's just sort of an unnatural situation. So the compost does have a lot of nutrients in it, but it's just it's not available as immediately to the plant as like your fertilizers. But the Harvest Supreme, yeah, that chicken manure is a great source of nitrogen still. And so it's good to do the compost and some fertilizer for your plants. The compost for its organic matter benefits and also for its nutrition. And then just the fertilizer for its nutrition. So that is basically what I had today. those were some of the most important things that I thought people should know about soil. Just the fact that it's not just dirt. There's so much life going on under there. There's a billion organisms in a single pinch. And so something that I really like to go by as a gardener is feed the soil, not the plant. Because all of that life, it's extremely complex under there. It's an ecosystem that's just as complex as any other. So if you are doing practices that nurture life in your soil, if you're not adding all of these like immediately available synthetic chemicals, if you're doing maybe more organic practices, if you're adding that organic matter, then your soil will be healthier and that will make your plants healthier, which ultimately is what we want as gardeners, is big, beautiful flowers. And, yeah.
Can you talk a little bit about mycorrhiza?
Yeah, sure. So this is, mycorrhizae are fungi and bacteria that form symbiotic relationships with plant roots and help them take up nutrients, help them scavenge for water. The filaments of these fungus are just so much smaller than even the finest root hair, so they can just travel farther. They can go into those micropores and get some more water and nutrients from those. And they greatly expand the root system of the plant, the effective root system, which is huge for drought, like surviving drought conditions. If your root system is twice as long, maybe even 50 times as long, then that's just going to help you survive drought situations. And so this is something, and our biotone fertilizer also has mycorrhizae in it. We recommend this for anything you're planting, whether it's vegetables or trees, because something like 90% of plants on the planet have relationships with these fungi and bacteria. Thank you. And so adding some of this into your soil when you plant things is going to ensure that some of these are there, and it will provide those benefits to your plants. Yeah, did you have any other questions about, or is that clear?
Is this like a granular fertilizer?
This is a granular, and it's 433, so it's pretty balanced. Did you have a
So if
question?
you have micropores, it's good to have them.
Sorry?
But if you have macropores,
If you have, well, it also depends on how much organic matter is in your soil, because these guys can also kind of like live on that organic matter. So, wait, could you say your question again?
So I was comparing the pool size to the need for the mycorrhizae,
Yeah.
because if it helps when there's tiny little pores, does that really give you much benefit if you have macropores?
Gotcha. Well, it can help when there are tiny pores to get more water and nutrients, but the idea is more that it just expands the overall mass of the root system. So it'll the filaments of the fungi will go like farther down into the soil.
Okay.
So even if you don't,
regardless of this.
yeah, regardless, even if you don't really have pore sizes, still this is gonna let your roots go farther, wider. Yeah, to let you more nutrients.
Steroids for plants?
That's what those like 16, 16, 16.
Yeah.
That's
No,
what
but
that is.
the mycorrhiza.
Yeah. Yes.
What about adding bone meal to your soil?
I'm not as familiar with. I know like people do that for bulbs, and I think that that's a nutrient thing. Like maybe calcium and magnesium, I think, is rich in for bone meal. So if you, you can add that when you're planting bulbs. I would add a little bone meal or.
What about just regular sandals and stuff?
I mean, if there's no evidence that it's really needed, then I wouldn't really worry about it. But then if your plant seems like it's getting sick, then maybe you might do a soil test to see if that could be it.
Because we were told to add it to acidic soils.
To acidic soils.
Yeah.
It would help break down the pH of an acidic soil, because the magnesium and calcium, those actually increase the pH. They make it more alkaline, less acidic. So, you could do that if you need to have an acidic soil. Yes.
I have a question about tilling raised beds.
Okay.
You know, if I have raised vegetable beds and it's a nice loose soil and I add compost every year at the beginning of the season,
I don't know where she put it.
should I be tilling it or should I not? I usually just stir it all up.
Yeah.
But would it be more advantageous to just put it on top?
For a raised bed, it's not gonna matter.
Doesn't matter.
It's because you're probably just growing like annual tomatoes in it. You're probably not growing like trees in it.
Right.
And at that scale, you're that's
Doesn't matter.
It doesn't matter in a raised bed. Raised bed is kind of a whole new different like thing. Yeah.
Do you have any suggestions for trying to get away from this chemical fertilizer on lawns? Like, is there something better we can do for lawns, especially in this climate where there's so much rain and so much leaching? Or is it just the way lawns are?
It's partially kind of just the way lawns are. Like, the idea of having a pristine, green, completely uniform lawn is completely unnatural. Like, nature, as we know, likes to throw up weeds and make things all crazy. So, you can use organic fertilizer on your lawn. I know lawns are a big source of nitrogen pollution because people just throw a ton of nitrogen on it to make it beautiful. But then a lot of it just leaches out. So I would go with an organic fertilizer, if possible. Or sometimes we just have to like change our idea of what like a beautiful landscape looks like, and maybe a perfect lawn maybe isn't part of that. I don't know, but you can use organic fertilizer for lawns, yeah. Any other questions?
I have questions, but it's probably personal situations in general.
Yeah, and I can answer questions about that.
Thank you.
So you're welcome. And thank you guys so much also for taking the time to listen to what I have to say. I hope that I have helped a little bit with your understanding of soil. But I just want to invite you to go home and just play in your soil and get to know it and just notice, like, compare it to these soils. Maybe go on Soil Web and see what it is, but just start to know your own personal soil, and that will help you manage it better.
My soil, in the spring it starts out okay, but by the time the summer hits and it's all dry, it's like harder than a rock.
Yeah.
And it doesn't seem like whatever we add seems to help that at all.
Yes, and that is another thing that I meant to mention. So, farmers in the Midwest who have had a long history of tillage and compaction, they've started switching to no-till systems where you don't till it, and a lot of they like leave all their plant residue there. And even with that super intensive addition of organic matter, they're still only increasing by 1% every 5 years. So forming soil is a very slow process, and it's like a year's commitment to really see changes in your soil structure. If you compost really diligently, it's still going to take time to see that. And in that case, maybe you would mulch in the spring and the fall to get a lot in there.
But not filling
And it probably is necessary to maybe do some tilling, like she said, that initial thing just to work some in, because I was dealing with soil like that in a certain situation, and it was just brick in the summer. So you have to first wait until it's wet enough to work. So like if after it's rained a couple times, maybe it's wet enough. And then you probably want to till it to work in some of that organic matter just to get some of it. Yeah.
It's too wet.
It's too wet, right? And that's the thing with clay is it gets super wet, super dry, super extreme.
So till a little bit?
When you go to add your organic matter in the fall, then you could till a little bit just to work it in. That first year or two, you might just have to work it. Anything in there. After that, I would try to just do the mulching on top and let the worms, hopefully some worms are there now. Yeah. Okay.
Thank you.
Yeah, you're welcome. Yeah, thank you guys so much. Really good to see you.